Hi everyone, Namaskara. Welcome to Karnataka KCET and Boards. I'm Diksha Kaushal, your chemistry master teacher. So I hope so. You all are good. Hello, Mandar, Khush, Prajwal, Abhishek. Yes, hello. So how are you all, and how's your preparation for KCET going on? And are you liking the classes or not? Everybody in the chat box, I want to know that from you guys, that are you liking what we are doing in chemistry? Is the sequence good, or you have some suggestion, right? So as we have completed, after completing chemical kinetics and electrochemistry, I got some suggestions that ma'am, we want practice of the physical chemistry numerical as well. So that is why now I have taken up electrochemistry previous year questions, right? As we have just done the theory part of this thing, so it will be very easy for you to do the numericals and to know that what are the questions that are exactly asked to you, right? So similarly, we will do that in the next lecture. We will do this the same thing for chemical kinetics. Okay, so you will get a perfect idea on what are the important topics, and what I have taught you is that actually from your previous year question, is that what you need to do or not, right? With proof, I am telling you everything. Okay, guys, so liking, very good, very good. So everybody, green hearts in the chat box for your Diksha Ma'am. Yes, everybody. Yes. Now, okay. So just give me a minute. So let us start with the questions. So now, first of all, what I need all of you to do, take up some notebook, right, and some pen. Try to solve the questions yourself, because it's not like that I am just teaching you and you're like, okay, ma'am, you are teaching us. I'll do that in the exam hall. Now, this is not going to happen, right? Trust me on that. Trust me. These are the questions, right? Direct these kind of questions will be asked to you in the exam, right? And then if you practice yourself, right now, if you try to do it yourself, even if that question is wrong, even if you answer it wrong, even if you answer it right, if you answer it right, then it will stay in your memory. But for example, you are not able to answer it, you are totally blank in this. But if you try to read the question yourself, in a long run, you will be able to recall whatever you have studied here on this channel, right? So that is my advice to you. So have one notebook along with you and one pen, so that you can write down the question, not the question, just write down what is mentioned here and try to answer, and also write it down in the chat box that what are you thinking, that how we can solve this question, right? Okay, so I'm going to show you the first question here. Miss, yesterday's electrochemistry, can I watch today? Yes, you can definitely watch today's lecture, because in yesterday I basically talked about some of the theory parts, right? And the formulas the formulas that I talked in yesterday's lecture is going to directly apply here. So basically, yesterday lecture, what we did, Faraday's first and second law, from there we are just going to apply the formula. And about the conductance, the theory part I have done in yesterday's lecture. Today I'm going to do the numerical part, so you can definitely watch this lecture. Yes, okay, but those students who have not watched Nernst equation, or who have no idea about what is Nernst equation, they should not watch this video, because for them it was be very messed up thing. If you don't know what is electrode potential, what is E naught cathode, what is E naught anode, you won't be able to answer the questions from Nernst equation, right? Okay, yes. Yes, Nancy. Okay, very good evening. Very good evening. Now, so one of my old students is also here, right? So now everybody, let us see that on your screen we have the first question. These kind of questions can be asked to you, and can you all tell me, just by the glimpse of it, that what exactly this question is from? Is this from Nernst equation? Is this from Faraday's law? Is this from Corlosh law? Is this from degree of dissociation? Right? Everybody in the chat box. Yes, yes, Mandar, Nancy, Prajwal, Srinivas, Khush. Yes, okay. So now, first is, now I told you we have done this kind of numerical in yesterday's class, last to last class as well, right? So now this is, I think, your NEET 2020 question. Not NEET 2020, this is your KCET 2020 question. Yes, I have a habit of speaking neat. No. So this is a KCET 2020 question, right? So I have picked up questions from last 5 to 10 years, right? You can go through the previous year question of KCET. I have picked out the best questions from there, right? Okay. Okay. It's Mandar. Okay. Now, first is given is what is given to you. They have given you some E naught value, right? Another E naught value is given to you. They are asking you the equilibrium constant for the reaction taking place in the galvanic consisting. Now you need to tell me what is the formula. Everybody in the chat box, what is the formula of this thing? Everybody in the chat box, what is the formula? Everybody in the chat box, what is the formula? And what they have given us here? Nernst equation. Is this from Nernst equation? They are asking you the equilibrium constant here. You need to tell me the relation between E naught cell and equilibrium constant. This is actually a part of Nernst equation only, but not exactly Nernst equation. We know that what is Nernst equation? Nernst equation is E cell equals to E naught cell minus 0.059 divided by N. Then you have log, this is QC, right? But when we talk about at equilibrium, we know that at equilibrium, E cell equals to 0. So in that form, this formula will become E naught cell equals to 0.059 divided by N. Then you have log Kc. Now this Kc is the equilibrium constant. This is the formula that we are going to use. I have already given you the formula that we are going to use. Now you need to tell me what all we need to find, right? They are asking you to calculate the value of Kc here, right? This is what they are asking you. Now you need to find the value of N and you need to find the value of E naught cell. These are the two things that you need to find. After that, put it in this formula and you will be able to answer what is Kc, that is equilibrium constant, right? So now let us see how to find the value of E naught cell. That is our first question here, right? So let us see how to calculate the value of E naught cell. I am going to copy this thing here, right? And then we are going to find the value of E naught firstly, right? We are going to find the value of E naught firstly. After that, we will put that in the formula, right? Now for E naught, what is the formula of E naught cell? Everybody in the chat box. E naught cell is equals to, this is your previous year question only from KCET, right? So this is E naught cathode, this is E naught cathode reduction potential minus of E naught anode reduction potential, right? E naught anode reduction potential, right? Okay. So that means we need to have the reduction potential of both of these cases, right? That is this one and this one. So firstly, let us see which is cathode and which is anode. Can you tell me that? Everybody in the chat box. Very, very small points here, right? Very, very small points here. Now, first thing is E naught cathode, E naught anode is given to you. First thing is we need to see which is cathode and which is anode. For that, we need to see the reduction potential of both of them, right? So E naught of Fe reduction potential. Reduction potential means, here is this reduction potential. It is going from +3 to +2. That means oxidation number is decreasing. That means definitely this is your reduction potential only, right? Okay. What about this one? Here you have from 0 to -1. Here again, it is decreasing, right? 0 to -1. Here it is from +3 to +2. Here it is from 0 to -1. That means again, oxidation number is decreasing. They have given you reduction potential. This thing is to clear to us that they have given us reduction potential, right? We know that cathode will be one which is under reduction and anode is the one which is under oxidation. That metal will go under reduction which has more reduction potential. Now, can you tell me which has more reduction potential? Everybody in the chat box. First thing is to find out which is cathode, which is anode, right? I can just tell you that, okay, Fe is cathode. Why, ma'am? Why Fe is cathode? You need to tell me the answer, right? So that is why step by step I am telling you the reason for all the things that I am saying, right? So here, this will become your cathode, right? From Fe3 positive to Fe2 positive, that is your cathode, right? That means iron is acting as a cathode, right? Okay, so that means here you will write E naught of, cathode means E naught of Fe3 positive to Fe2 positive, that is your cathode, minus of E naught of, what is oxidation? That is oxidation, that means anode is getting oxidized, right? This is the, if this is cathode, this is under reduction, then this will be under oxidation, right? This is I2 to I negative. Understood? See, this is under reduction, this is under oxidation, right? But we need to write the reduction potential of both of them. That is why I have mentioned I2 to I negative here, right? Otherwise, if you talk about, ma'am, what will be the form, what will be the full reaction here? The full reaction here is going to be, that this is the cathode side, right? So it will be, cathode means reduction. So it is Fe3 positive is undergoing Fe2 positive, right? Here what is happening? Reduction is happening. Here oxidation is happening, right? But they have given us the reduction potential. That means the opposite of this thing must be happening. That is I negative to I2. I negative to I2. This is the full reaction that is taking place here. Now, everybody tell me, is that clear to all of you or not? This is the exact reaction that is taking place here, right? Is there any confusion related to, ma'am, how you judged that this is cathode, this is anode? As you can see here, how you predicted this reaction, right? Now, this is oxidation number is decreasing. This is reduction part, right? And here oxidation number is increasing from -1 to 0. So this is the oxidation part. That is why here this is the cathode part and this is the anode part. But we have to take the reduction potential of both of them, right? So that is why it is not from I negative to I2. They have given it from I2 to I negative, right? Okay, everybody in the chat box, tell me, is this thing clear to all of you or not? Now just put the value here. E naught cell is going to be, this is 0.76 minus, right? This is 0.55. That will turn out to be this is 17521, 0.21 volt, right? 0.21 volt, right? Okay, that is going to be the value of E naught cell, right? Once you have the value of E naught cell, then just put this in this formula, then just put this equation in this formula. That will become E naught cell is 0.21 equals to 0.059, and you can also say this, you can also mention this as 0.06, because this, so they have told you in the question itself that point is 2.303 RT by F is equals to 0.06. So they have already given you it as 0.06, right? Okay, yes, equation is not balanced. I know the equation is not balanced. Now this is N, right? Because right now we have not calculated the value of N. Still we have one value, that is N, that we have not calculated yet. So to calculate the value of N, let us see this reaction, right? Can you see this reaction? Here Fe3 positive is getting converted to Fe2 positive, but here you have two atoms of iodine. Here you have one, so it will be multiplied by 2, right? So if you see here, this is -2 and this is 0, right? And this is +3 and this is +2, right? So if I talk about -2 to 0, right? In the anode part, 2 electrons are lost here, right? So we can say 2 electrons are lost here. But ma'am, if we talk about +3 to +2, here just 1 electron is gained, because in the reduction you have gain of electron. So here what we will do, we will multiply this by 2 and this also by 2. Now you have how many electrons? This is 3, 2, 6. This is plus 6. And this is 2, 2, 4. This becomes plus 4. Right? So this becomes plus 6 and this will become plus 4. Right? So that is how you will get your balanced equation. Right? That is how you will get your balance. This is 3 into 2, 6. This is 2 into 2, 4. So this is plus 4. This is how you will get the balanced equation, that actually this is going from plus 6 to plus 4, where again the difference is of 2 electrons. Here on the anode part, it is getting lost. On the cathode part, it is getting gained. Right? Okay? Understood? So 2 is n value. Right? So value of n will become equals to 2. Number of electrons gained and lost will become equals to 2. Right? Okay, everybody? Got it? How to do this? There are 3-4 things in this question that you need to know. First is how to calculate the value of E naught cell, then how to calculate the value of N. Right? After that, the third step is just put this value here. Here N will be equals to 2. That will become equals to 0.03. This is log Kc. Right? And this is 0.21. So log Kc will become equals to 0.03 divided by 0.21. Is it? No. It is equals to 0.21 divided by 0.03. This decimal will cancel out, and 37321. So it will become log Kc is equals to 7. That means you have to take the anti-log of 7. Can anybody tell me what is the anti-log of 7? This we have done in log and anti-log, right? You can see the first lecture that I have taken on this channel. That is a basics, right? That I have taken log and anti-log in detail. I have covered how to solve the value, right? Okay, yes. Ma'am, how you wrote the reaction? I'll tell you how I wrote the reaction. Yes, by the time, okay. So now, firstly, let me tell you how I wrote the reaction. See, as I told you, firstly, I need to see which is acting as cathode, which is acting as anode, right? So I know that there are two things happening. First is Fe3 positive is getting converted to Fe2 positive. I2 is getting converted to I negative, right? But here, do I have both as reduction potentials? Yes. Here also plus 3 to plus 2, that means it is decreasing. Here also 0 to minus 1, that also means it is decreasing. That means both we have reduction potential. Next is, more is the reduction potential that will occur at cathode side, right? So, the more is the reduction potential, it will cause the reduction. If it has less reduction potential in comparison to other thing, that will cause oxidation, right? So, when we compare these two things, it will act as a reduction, right? Here the reduction will happen because it has more reduction potential. That is why this will act as cathode side, and this will act as anode side. This will act as anode side. In anode side, you have loss of electron. That means this will be opposite, right? Because here they have written reduction potential. In anode side, you have oxidation. That is why this will be opposite. It will be I negative to I2. And here it will be same because at cathode side, you have reduction. So it will be Fe3 positive to Fe2 positive, right? After that, how I balanced the equation, right? Okay, ma'am, taking the value of n is confusing. Second is how to balance the equation, right? So that is also very simple, right? So what I did, firstly, I saw that number of atoms should be balanced, right? So here you have I negative, you have I2. You have two molecules of I2, you have one molecule of I, right? So what I'll do, I will make both of them same here. Number of atoms should be same. So I made this as 2 also, right? So once this is 2, now I know that number of atoms are same everywhere. But here I saw that it is not 2 negative, it is 0. That means 2 electrons are getting lost. On anode side, there is loss of electrons. So 2 electrons are getting lost here. But now I saw that if 2 electrons are getting lost here, then this is 3 positive, this is 2 positive. Here only 1 electron is getting gained. So that because of that, we want to make number of electrons gained and lost equal. So that is why I multiplied this by 2 and it became plus 6 to plus 4. Again, I have 2 electron gain. So that is why n will become equals to 2, right? That is why N will become equals to 2. Right? Okay? Yes. Okay, guys. Now, what is the antilog? Antilog is simple. Antilog will turn out to be which thing? I told you, whenever you have positive thing inside the antilog, take it as 10 raised to power that thing. So, it will be 10 raised to power 7. So, answer will be 10 raised to power 7, or you can write it as 1 into 10 raised to power 7. So, the option which will be correct is 1 into 10 raised to power 7. That is option number 3 is the correct answer. Right? Option number 3 is the correct answer. Okay, guys, got it? Okay, guys, got it, everybody? Everybody got it? Yes? Now, these kind of questions are what they will ask you, right? Based on Nernst equation, based on they will ask you find the equilibrium constant from different things, right? So, as you can see, I have picked out previous year questions only, so you will get an idea that what ma'am is saying is actually correct, right? Now, next is, now try to do it yourself, right? Try to do it yourself. Now, reaction is given to you, right? This is also your previous year question only. Reaction is given to you and the reaction is given to be, and the reaction is given to be, just give me a second. Reaction is given to be which thing? Reaction is H2 plus 2 AgCl, right? Let us write it here. H2 plus 2 AgCl, H2 plus 2 AgCl give rise to, this is 2 Ag plus HCl, 2 Ag plus HCl, right? I think it should be 2 HCl, right? Okay, so this is the question. They are asking you to calculate the value of equilibrium constant. Again, the same formula will be applied, that is E naught cell equals to 0.06 divided by n factor log of Kc. Again, this thing will be applied, right? Again, the same thing will be applied. Now, again, you have to calculate the value of E naught cell. Now, this question is actually simple as compared to the previous question. Why? Because here, reaction is already given to you, right? So, you don't have to write the reaction yourself, right? In the previous question, at least there was 5 concepts that were applied in that question. So, I will consider it as a difficult question when we talk about KCET, right? But these kind of questions are also asked, as you can see, right? So, now, let us see, to calculate the value of E naught cell, we have to see that which is cathode and which is anode, right? So, now let us see. This is getting converted from 0 to, this is getting converted from 0 to, here H is in +1 state, so it is +1, right? That means the oxidation number is increasing, right? Here oxidation number is increasing. Can I say here there is a reduction? What is happening, right? So it will be on the anode side. It will be on the anode side, right? Now, if you talk about Eg and 2Ag, here it is 0, right? Here it is 0, and here Ag is in +1 oxidation state, right? It is in +1 oxidation state, okay? Now, what you need to see here is, if it is in +1 oxidation state, then what we will do, right? So, it is, but here we have 2 Ag, right? So, here also it should be +2, okay? Here also it should be +2, because here 1H has +1 oxidation. This is -1. 2H positive will have +2. So, it will be +2 here, right? Okay. But again, the oxidation number is increasing only, right? If you talk about on this side, here it is +1 for 1 Ag, right? So, can I say it is +1? This is -1. For 2 Ag, it is +2. It is going from +2 to 0. That means here what you can see, oxidation number is decreasing, right? So, can I say oxidation number decreases, or here we can write this is called a reduction, right? This is called a reduction, right? Okay. Till now, are we able to see which is oxidation, which is reduction, right? Okay. Abhishek, we can round it off. It is 0.059 is 0.06 only, right? Okay, to make the calculations easy for us. Now, this is reduction part, this is oxidation part. We know that how to calculate the value of E. Firstly, you need to calculate the value of E here. So, I am just drawing a line here. So, E naught cell is equals to E naught cathode minus E naught anode, right? Now, let us see what is given to you in the question. E naught cell at this for cell. Oh, E naught is given to you in the question. No, that is so simple. Even simple, yeah. Nothing was there, right? So, here E naught is already given to you, and here E naught is given to be 0.022 volt. For example, they have not given you E naught in the question. They have given you the value of cathode. Cathode is what? This one. They have given you the value of Ag positive to Ag. Then also answer will be 0.22 volt, right? Okay. Because minus 0 means anode is 0 only. The reduction potential of hydrogen is 0 only. So, it will be 0 over here, right? So, even if they give you reduction potential of Ag or they give you directly E naught, answer will be this thing only, right? So, answer will turn out to be E naught cell is equals to 0.022 volt, right? Then what we have the N factor here. So, 2 electrons are getting lost here, right? And 2 electrons it is gaining here. Plus 2 to 0, that means 2 electrons it is gaining. So, N will be equals to 2 only. So, answer will be E naught means 0.22 equals to 0.06 divided by 2 log of Kc, right? Log of Kc, is it the same as the previous one? No, it was 0.022, right? Yes. Equilibrium constant 27 degrees Celsius, 25 degrees Celsius. Wait a minute. Here it will be 0.03. This is log Kc, right? 0.22. It will be log Kc 0.22 divided by 0.03. So, it will be log Kc is equal to 22 by 3, right? You need to find out the value of this thing, right? 22 by 3, wait a second. 22 by 3 will be equals to, just give me a second, 7.33, right? That is equals to 7.333 something. So, I'll take it as 7.34, right? It is somewhat same as 10, it is somewhat same as 10 raised to power 7 only. If I get a rough idea, if you want to get a rough idea of this, so if log Kc of 7 is 10 raised to power 7, right? So, 7.34 will be also 10 raised to power 7 only. So, the answer should be this one, because here it is 10 raised to power 5, here it is 10 raised to power 8, here it is 10 raised to power 4. But still, if you want to calculate only that, ma'am, I want to calculate the value of this anti-log. So, here also we will use the kind of approximation only. So, this will be 7.34, right? So, that means Kc is equals to anti-log of 7.34. So, that will become equals to, that will be, this I have told you how to calculate anti-log. This I have told you in log and anti-log, right? Okay. So, this is equals to 7 plus 0.34, right? So, what is anti-log of 7? Anti-log of 7 is 10 raised to power 7. Anti-log of 0.34 is equals to 0.34 is equals to 2 only, right? So, that is equals to 0.3 is 2, no? So, answer will be 2, right? So, here it will be Kc will be equals to 2 into 10 raised to power 7, right? That is equals to 2.8 they are saying, right? Somewhat similar only, right? So, it is equals to 2.8 into 10 raised to power 7. That becomes your answer, right? Is that clear to everybody or not? Is that clear to you guys or not? Everybody in the chat box, is that clear or not? I have specially picked out some tricky questions for you so that I don't want you to feel that, okay, only the exam is going to be simple. Yes, the exam will be simple, but also there will be questions like this that you need to practice, right? Okay, that's why I have picked out not very direct question. I have specially picked out those questions that you will be like, okay, ma'am, I need your guidance. Please teach us these kind of questions, okay? Yes. Now, next one is on your screen. 2018 question, right? Okay, everybody. Yes, try to answer it. Yes, it wasn't tricky though. Then that means if you feel like, okay, ma'am, that was an easy question, then that means you can easily crack KCET. Trust me on that. For NEET aspirants, for JEE aspirants, this is very simple question. But when we talk about the level of KCET, yes, this is among the tough questions. Okay? Yes. Okay, guys. Now, the charge required for reduction of 1 mole of MnO4 negative to MnO2 is. Right now, these kind of questions are also frequently asked in your KCET exam. Right? So, what exactly this means? Right? So, I have not taught you this kind of question in theory part. That is why I have picked it here. The charge required for the reduction of 1 mole. Right? That means you need to remember one thing, that 1 mole of electron, the charge on 1 mole of electron is called 1 Faraday. Right? So 1 mole of electron is called 1 Faraday. We need to see how many mole of electrons are gained or lost in this particular reaction. So if you talk about this reaction that says MnO4, 2 negative or negative, 2, it is converted to MnO2, right? Just find the oxidation states here. Try to find it. So this is X minus. For oxygen, it is minus 2. So minus 2 into 4 is minus 8 is equals to minus 1. So X will be equals to plus 7 here. And this is X minus 4 equals to 0. So X will become equals to plus 4 here. Right? Okay. X will become equals to plus 4 here. Right? Okay. Should we just make the value negative? Yes. If they have given you oxidation potential, then you need to just make the value opposite. If it is negative, just multiply it by a negative. Right? That's it. Okay. Not add. You need to multiply it by negative. Right? The sign will be opposite. Right? Now, the oxidation number is from plus 7 to plus 4. Oxidation number is decreasing, right? Oxidation number is decreasing. That means reduction. So, can I say that how many electrons are getting gained? Here 5, 6, 7. That means 3 electrons are gained by 1 molecule. To make 1 molecule, 3 electrons are gained. So, for 1 mole, if you want to make 1 mole, then 3 mole of electrons are gained by 1 mole, right? 3 mole of electron are gained one molecule of MnO4 negative, and 3 mole of electron are gained by 1 mole of MnO4 negative, right? That means, what do you mean by 3 mole of electron? 3 mole of electron means 3 Faraday is gained by 1 mole of MnO4 negative, right? To make MnO2. So answer will be 3 Faraday. Answer will be 3 Faraday. That is answer B is the correct answer, right? B is the correct answer. Is that clear to everybody or not? Is that clear? Yes, guys. Okay. Now, coming to the next question here, that is the resistance. Now, this is based on Faraday's law, right? This is based on Faraday's law. This is not based on Faraday's law. This is based on resistance conductivity, right? The resistance of this molarity, right? This is the molality is given to you. KCl solution is this. That means resistance is given to you. Conductivity of this much solution is this. Conductivity means rho. Conductivity is given. No, wait a minute. The resistance is given, the conductivity. Conductivity means kappa is given to you. Right? Conductivity means kappa is given to you. Cell constant they are asking you. That means they're asking you L by A or G star. So I told you a formula in the last class that has been made through this formula, that is R is equals to rho L by A. That means 1 by G, that is conductance, is equals to 1 by K, that is kappa, right? Now what is L by A? That is cell constant. This is K kappa, this is conductivity, 1 by K, this is 1 by G. So from here we have this equation, very, very important equation, that is G into G star equals to kappa. Now they are asking you the value of G star. So G star will be equals to kappa by conductance. What is the value of kappa? Kappa is 0.146 into 10 raised to power minus 3. What is the value of G? That is conductance. Conductance is not given to you, resistance is given to you. So this G is opposite of resistance, so it will be R. So that means if you write kappa here 0.146 into 10 raised to power minus 3, there you will have the resistance, that is 1500, right? Okay. This S is nothing but per ohm, and here you have ohm, so per ohm and ohm will cancel out each other. So answer will be in centimeters, per centimeters, right? And what will be the answer? You just need to solve this. So answer will be, wait a minute, 14 into 15 only, right? So answer will be 146. You just need to, okay, let me see, 0.146 multiplied by 1500, 219, yeah, 2 point. So this is 219 multiplied by 10 raised to power minus 3, that is 0.219 centimeter inverse. So answer is 0.219 it is, no? Yes. So answer is 219. This is the answer. A will be the correct answer, right? A will be the correct answer. Okay? A is going to be the correct answer here. Right, everybody? Okay. Simple mathematics. After till here you have chemistry. After this you have mathematics. Okay. 0.194. 0.146. 1500. How come yours is coming out to be 0.194? Mine is coming out to be 0.219. Okay, chalo. Now next one it will come out to be 0.219 only, right? Next question is 1 liter solution of MgCl2 is electrolyzed completely by passing. Now from current and time, I know that this is from Faraday's first law, right? This is from Faraday's first law, right? We are clear on that this is from Faraday's first law, right? So now we need to see what exactly they are asking you. They are asking you the original concentration. Forget about concentration. Try to firstly answer what is weight deposited. Now weight deposited is equals to ZIT. What is Z? Z is molar mass by N factor into Faraday multiplied by I into T, right? Now what is the weight? What is the weight deposited? Molar mass. 1 liter of solution of MgCl2 is electrolyzed completely by passing a current of 1 ampere. Current is given to be 1 ampere. Time is 16 minutes 5 seconds. So 16 into 60, that will become the seconds, right? So it will be 36, 36, 6, 7, 9, 90. 965. है ना? So it will turn out to be 965. Because 5 seconds we have to add also, right? So it will turn out to be 965 seconds, right? Because 16 minutes into seconds and after that add 5 seconds into it. So it will run out to be 965 seconds. What is the molar mass? Now, ma'am, molar mass of which thing we have to take, right? So we take that how, see, in electrolysis, I told you yesterday itself, do you remember that what I told you? You have this beaker, you have anode, you have cathode. Anode will be vanished, but on cathode you have deposition, right? Do you remember that? On cathode you will have deposition. Why? Because on cathode you have gain of electron, and after that gaining the electron, it will be deposited on the electrode. But in anode there is loss of electrons and it is jumped into the ions. Do you remember that? That is why on cathode, that means we are going to take up the positive ions here, right? So positive means we have Mg2 positive, Mg2 positive, right? Mg does not exist in Mg positive. It exists. Have you ever seen in chemistry Mg positive, Mg3 positive? No, right? You have seen Mg2 positive. That means 2 electrons it is gaining, right, to become Mg, right? So that is why here what will happen? N factor is going to be 2. Faraday's 96500. What is molar mass? Molar mass of Mg is given to be 24, and even if it is not given to you, you should know that it is 24, right? So that is the weight deposited here. Anybody in the chat box, any doubt here? So this is so simple. 965, 965 will cancel out. This is into 12 only, right? So it will be 12 by 100, right? That is 0.12, right? 0.12 is the weight, right? 0.12 is the weight. Okay, guys? 0.12 is the weight. Is there any problem in that? Is there any problem, guys? Please speak something. Please speak something. Okay, right? So that is 0.12. Now they are not asking you the they are not asking you the weight deposited. They are asking you the original concentration here. So concentration means we know that they are asking you the molarity. Usually we express it in molarity. That is number of moles, that is weight by molar mass multiplied by volume in liters. Volume in liters. We know that volume is given to be 1, right? It is given here. 1 liter of solution, right? So now molar mass is 24 only, but weight is 12 divided by 100, right? So it will be 2. So it will be 1 by 2 multiplied by 1 by 100. So it is 0.5 multiplied by 10 raised to power minus 2. Right? So let us see what is there in the option. 0.5 multiplied by 10 raised to power minus 3. Because this is 0.5 multiplied by 10 raised to power minus 2 is nothing but 5 into 10 raised to power minus 3 molar. Right? Here also the hint is given that the concentration is in the molarity. Capital M means molarity. So answer is 5 into 10 raised to power minus 3. Right? Okay, everybody. Now tell me, is this clear? Otherwise, I am not going to solve the next questions, right? Okay. Everybody in the chat box, now tell me. Sitting there, relaxing, not even uttering a single word. That is so bad on your part, huh? Okay. Do you want me to lose my energy? No, then you have to also speak something. I can't see, understand, I can't see your faces through the camera, right? What I can see is your chats only, right? That is my motivation. That is my point that, okay, you guys are able to understand, right? So now the next question is, here, this is also a very important question. This is, I'll give you a hint, right? This is based on conservation of Gibbs energy, right? That means this is based on that Gibbs energy is additive in nature, right? But electrode potential is non-additive in nature. So let us see this here. They are saying that you have the conversion of Mn7 positive to Mn2 positive, right? This conversion you have, right? This conversion you have Mn7 positive to Mn2 positive. Then from Mn7 positive to Mn4 positive you have to find out. But from Mn4 positive to 2 positive, that is 1.2. right? So that means this is given out to be 1.2. I'll take it as E1. This is my E2 and this is my E3. E3, in all of this, reduction potential is given because the oxidation number is decreasing everywhere, so reduction potential is given. E3 is equals to 1.5 volt. This is equals to nothing. This we have to calculate. And E2 is equals to 4, 2 plus 2 is equals to 1.2 volt. Right? Now calculate the N factor. N3, now here it has lost 5 electrons. Here it has lost how many? 3 electrons. Here it has lost 2 electrons. Right? Now tell me, is this thing clear to all of you or not? This we have done in the Nernst equation segment, right? Where we have done the theory part of Nernst equation. There I told you the conservation of energy, right? Okay. Now from here, I know that if I want to calculate the value of E1, then I can't say that E3 is equals to E1 plus E2. That is not the case. But I can say that delta G naught is equals to delta G. Here also, I don't know why I always forget to write naught here. Right? This is also not. Right? This is also not. This is also not plus delta G naught. This is 3, this is 1 and this is 2, right? This is 3, 2, 1, okay? Power of Mn isn't visible, but now is this chart visible to you? Is this chart visible to you? Let me clarify that also. Here it is plus 7, 2 plus 2. Here it is plus 4, 2 plus 2. And here it is plus 7, 2 plus 4. I think now it is visible, right? Is it? Now that becomes your total question, right? So we will solve it by that delta G. We will solve it by that delta G naught 3 is equals to delta G naught 1 plus delta G naught 2, right? And that is equals to minus NF E naught cell. So it is minus N3 F minus N3F E naught 3 cell, right? This is minus N1F E1 naught. This is minus N2F E2 naught. Here Faraday will cancel out each other and negative will also be cancelled out. So here it will be N3 E3 naught is equals to N1 E1 naught plus N2 E2 naught, right? Then what we have to find out is E1. So let us find out the value of E1 from here. E3 it will be N3 E3 naught minus N2 E2 naught equals to, this is E1 naught what we have to find out, so it will be E1 naught. So that will be the formula of E1 naught, right? That is going to be the formula of E1 naught. Now what you have to do, just have to put the values. E1 naught equals to, what is N3? N3 is 5, right? Just put the values 5. What is E3? E3 is given out to be 1.5, right? So it is 1.5 minus, what is N2? N2 is 2 and N1 is 1. N1 is 3. N1 is 3, it is 2, and this is, I think, E2 is 1.2. E2 is 1.2, right? So this will become your answer. This is E1 naught, this is 3, this is 15, 3, 3, 15 into 5, right? So 15 into 5 is 45, right? 4.5. Okay, 15 into 5, 66 it will become, right? 15, 30, 45, 60, 75. Yeah. 5 is 75. 7.5 minus 2.4 divided by this, it will become 1.7 minus 2 is 5. 7 minus 2 is 4. Right? So that will be the answer. Let me see what are the options that is given to you. Option is 0.1, 0.3, 2.1, 1.7. Wait a minute. Wait a minute. Hmm. 1.36. 1.3, so I can't see anywhere here. Option is 0.1, 0.3. It is 2 only, divided by 3 only, right? 15 into 5 only. So answer should be this only. 7.5, 2.4, this 1. What's your answer coming out to be? What is the mistake? Okay. 7 minus 2, 5. Okay, 5.1 into 3 divided by 3. Let me see if this is coming out to be true or not. It's coming out to be 1.7. Just wait a minute. Let me see if it is in the options. Yes, it is there in the option. So answer D is the correct one. Silly mistake, right? So answer D is the, sorry, D, not B. D is the correct answer. Okay, D will be the correct answer. 1.7, right? Okay. Okay, everybody. Very, very silly mistake I did here. It was supposed to be 5.1. I accidentally wrote it 4.1. That is why the answer was coming out to be something else only, right? So here it should be 5.1. 7 minus 2, 5. Okay? Okay, guys. 1.7 is the correct answer. Next is this one. The charge required for the reduction. Yes, 1.7 is the answer. Very good. The charge required for the reduction of 1 mole of MnO, this so we have done, isn't it? Repeated question, right? Repeated question, right? Next one, next. The electrolysis. Now, the electrolysis of the aqueous sodium. Now, this is based on product of electrolysis, right? Product of electrolysis. This we have not done because this is actually a full-on cramming thing, but I'll tell you a little about this thing. Right, this so you can go through that. This is more of to remember that which reaction will occur at anode and which will occur at cathode, right? So in the electrolysis of aqueous sodium chloride solution, which of the half cells, right? Don't worry, I will complete this, right? After completing the full syllabus, we'll go through the marathon, then I will complete the little topics that are left, right? But right now my focus is on the maximum portion that you are not able to understand yourself. I'll teach you that. After that, I'll guide you that what are the things that you need to understand yourself. Then after that, once you have completed everything, we will again revise. We will again do the revision, right? Now they are asking that in the electrolysis of aqueous sodium chloride. Aqueous sodium chloride means you have NaCl also, you have H2O also. So here NaCl means you have Na positive also, Cl negative also. Here also this H2O, when it is under reduction, it will give us H2. When it is under oxidation, it will give us O2. That is the main part of oxygen, right? That is the main part. The funny part is that in NEET exam, they will not give you these kind of things. In JEE, they will not give you the E0 values. They will not give you this thing. They will assume that you need to know that yourself, right? That is why in NEET, we teach that in detail because this you have to remember yourself. But in KCET, they will give you the values here. Now here you just need to remember the concept, right? Concept is the main thing for you in KCET, right? Cramming is not the main thing, right? So in KCET, what they will give you, even the student who don't know why they have given these E0 values, he won't be able to understand, right? So now first is what is the problem here? We know that at cathode there is gain of electrons. So cation is supposed to gain, right? There are two places for reduction. If H2 is getting reduced, then H2 will be formed. And if Na positive is getting reduced, then Na will be formed. Right? Now they are not asking you at cathode. Reduction will occur at cathode. They are asking you at anode. Right? At anode, there are two cases. First is if Cl2 is getting oxidized, it will give us Cl2. If H2 is getting oxidized, it will give us O2. So these are the two competitors of anode. Now your question is which will do what thing? So firstly, let us eliminate Na from there because it will happen at cathode. Right? Let us eliminate H2 also, where H2 is getting formed, because H2, H positive to H2 means there is a reduction is happening here. Again, this is eliminated. Again, this is eliminated. Right? Now you have two main things, that is the second part and the fourth part, that is B and D. Here electrons are getting lost and they are forming Cl2. That means definitely at anode. Here H2 is getting converted to O2. This is a very, very important reaction. In NEET and JEE, I tell students to remember this reaction. But for you, you don't need to remember this reaction. There is no use of remembering this reaction, right? So this they will give you. Now, when you talk about water, it is undergoing oxidation. It is going to give us O2. And here, as they have given you, the E naught value is 1.23. This is the oxidation potential that they have given you, right? This is again the oxidation potential that they have given you. How I can say they have given you the oxidation potential? Because in this also it is losing the electrons, and in that they have written E naught cell. That means they have given you the oxidation potential of this reaction. Here also oxidation is occurring and they have given you the E naught value. That means they have given you the oxidation potential of this reaction, right? Now, which reaction is going to take place? That is the main question. So always remember, at cathode, more reduction potential, at anode, more oxidation potential. That means at cathode, that reaction will occur which has more reduction potential. At anode, that reaction will occur which has more oxidation potential. 0.136 is greater than 1.23, right? So that means this reaction will win, and that means D will be the correct answer. Hence, D is your correct answer. You don't need to cram it, right? This is actually given in your question itself. You just need to remember this thing. That is a product of electrolysis. When you have two choices, which will win? At cathode, which has more reduction potential, at anode, which has more oxidation potential. That means less reduction potential, right? Okay. Yes, everybody. Yes. Okay. Now, next is last two questions only we have, right? Now, here you have the amount of current in Faraday is required for reduction of 1 mole of Cr2O7 negative ions to Cr3 positive, right? So now you have Cr2O7 negative to Cr3 positive, right? This is the thing that you have. Now see, this is 2x minus 14 is equals to minus 1. So 2x will become equals to which thing? This will become equals to 13. So x, wait a minute, 2x minus 14, this is minus 1 only, this will be minus 2. K2Cr2O7 it is, no, so it is minus 2. It is not minus 1, it is 2 negative charges are given to you, so it is minus 2, right? So here it will be minus 2. Because K2Cr2O7, it is K2Cr2O7. So it is after, it will be Cr2O7, 2 negative ion, right? So here it will be 2x minus 14 equals to minus 2, right? Because here it is -2, right? Oxygen has -2 and here also it is -2, iron is -2. So 2x is equals to, this is 14 minus 2 is 12. So x will become equals to +6. What about this? Here x is equals to +3. Now it's a very, very important question because students, they can easily do mistake here, right? Now understand one thing, that here you have two atoms of Cr. Here you have one atom of Cr, right? So here this will also be multiplied by 2, isn't it? This will also be multiplied by 2. If you see this very carefully, firstly, so you need to remember that here you have calculated for one atom and here it is for one atom, right? Here it is for one atom. One atom means 1 mole of Cr atom. So you can write it here, 1 mole of Cr atom. How many electrons are lost? 3 electrons, sorry, not lost or gained, are gained. 3 electrons are gained, right? And if you talk about, see, if you talk about not 1 mole, if you talk about 1 Cr atom, 1 chromium atom has gained 3 electrons. 1 mole of chromium atom, 1 mole of chromium atom has gained 3 mole of electrons. 3 mole of electrons, right? That means they are here asking you the amount of current Faraday is required for the reduction of 1 mole of Cr2. In this you have 2 atoms of chromium. 2 atoms of chromium, right? In this you have 2 atoms of chromium. So that means 2 mole. So 2 mole of chromium atom will have 2 into 3, that is 6 mole of electron, that is 6 Faraday, right? That is going to be the answer, right? That is going to be the answer, that is 6 Faraday. So answer is C is the correct answer, right? See, students usually they will mark 3 Faraday as the correct answer, though it is not given anywhere, right? But if they give you 3 Faraday, students will directly point it as 3 Faraday, ma'am, is the correct answer. But in reality, 6 Faraday is the correct answer. Is that clear to everybody or not? Right? Yes, how do we know the schedule of your uploads? Okay, so how do you know the schedule of my uploads? I'll try to fix it soon, right? Okay, I'll try to fix it, but otherwise on channel also, on the live also it is displayed, right? On channel also, I send you the link, right, on day only. I'll try to send you the link one day before, right? Okay, yes, everybody. So 6 Faraday is the correct answer here, right? Okay, everybody. Last question of today is H2O2. This I told you that fuels and batteries, this is the theory part. You have to do it directly from NCERT, right? They will ask you which is the reaction that will occur at anode, what is the reaction that will occur at cathode. Directly, it is just pure cramming, right? So H2O2 fuel cell, the reaction occurring at cathode is, right? At cathode, which reaction is occurring? Anybody in the chat box? At, this is the overall reaction. This is definitely not the correct answer, right? Okay, this is also definitely not the correct answer. Anybody in the chat box? At cathode, which reaction is occurring? At cathode, which reaction is occurring? Anybody? Okay, I'll try to upload it, guys. I'll upload it, yeah. Okay. Now, B will become the correct answer because this is the reaction that will occur at cathode site, right? This is the reaction that is going to occur at cathode site. Basically, in H2O2 fuel cell, you have H2 and O2. From there, you make water out of it, right? Okay, so B is the correct answer. Okay, Manda, don't worry, don't worry. That will happen, right? So, as you all know that, right, I am trying my best, right? So, right now it's just a starting phase. Right now I'm trying to know that what you exactly guys want, right? That is why I'm asking you that please write it down in the comment section. What is your demand? What you are weak in? Are you weak in practice? Do you want me to focus more on practice, more on previous year questions, and then only the priority theory part I should teach you, right? So I am going according to that thing, that I should teach you the priority theory part now, and side by side I'll do the practice also, so that you are well prepared for KCET exam. But I want to know what are the chapters that you find difficult, right? So that I can make a plan. I can make plan only if I know my students, right? So I want you guys to answer, to comment below what is the thing that you want, right? Okay, yes. Okay, so today I'll check the comments in all the videos, especially on this video, right? I'll check the comments, right? And I'll see what are your queries, what are the things that you want me to do, right? Do you want, like after this, I will be doing chemical kinetics previous year questions, right? So that you can get an idea what kind of questions are asked to you. After that, we will do solutions chapter, solid states, right? All these chapters we will do. Okay, guys? Okay. Short notes, how to present paper, how to tackle hard questions, and etc. Okay, Manda, do one thing, just copy paste this thing that you have written here and paste it on the comment section, because the chat will eventually vanish, right? But the comment will stay, so that I can take a screenshot of that and I'll make videos on that, right? Okay, yes. Okay, then bye. What sometimes things happen, right? So, okay then, bye guys, take care, see you all in the next class. That is going to happen on next week, right, where we will be doing chemical kinetics practice questions. And in between that, I want all of you to go through everything, like what we have discussed in chemical kinetics. I don't want you to come in the class totally blank, right, because I'll be picking up really good questions for you. Okay. Okay. Yes, so sorry. Yes, solid short has been cancelled. I'm so sorry. Yes, it has been cancelled. Yes. Okay, then bye-bye. Take care. See you all in the next class. Bye-bye.